Oh, I remember this. Anybody miss the Bill Gates stuff? Okay, yeah, that's where we stopped last time. Okay. So from here on, now when you have a solvent, you put acid into it, then you put base into it. So it appears there will be 3 chemicals, right? Solvent could participate. But then, according to this, you will see that the solvent is actually a spectator, and therefore your true acid and your true base will react with one another. Okay, so here the HL represents the solvent. So you have acid here, you have a base there. So the acid add into solvent independently, and then the base add into the solvent independently. Then you would write them like this. Okay, but then because they are both in the same solvent, and therefore both these will happen simultaneously, although the equation is written separately. But then the solvent itself, okay, the plus and the minus will react with one another. So notice in here, this is a reaction product with the acid, and then this is a reaction product with the base. So this is minus, and this is plus. Okay, so these two will react with one another to charge. So you get this. So all these 3 will happen in a mixture. Now you sum them up to get the net reaction. Then the solvent XL will cancel the HL on the left, and therefore the solvent is a spectator, leaving behind the net reaction. So the acid will meet the base directly, okay, and form the conjugate acid and base, okay? So the point here is just to indicate the solvent is a spectator. Then for an exam question, I might ask you to prove, write equations to prove that solvent is spectator. Then this will be what you need to write, okay? Any question here? So remember that you know how to write the equations. Write the equation. Okay. Now, some of the solvents are so-called amphiprotic solvents. Okay, remember the term. So amphiprotic solvents use HL to represent. So because they have both acid and base character. So here is a specific example for a amphiprotic solvent, which is water. So the water have both acid and base components. So now it depends on another chemical mixed with water. Then water will determine to behave as an acid or as a base. Okay, while methanol is also amphiprotic solvent. So here is the acid, and here is the base. Now, for a pure solvent, the two concentrations will be the same, right? And therefore, it's neutral. So this concentration equal to that concentration is 10 to the minus 7 molar, and therefore neutral. Same here. Now, as you add a chemical into the solvent, then these two concentration will change more or less. Okay, these two change. So when one concentration is higher than the other, then the solution in this case would be alkaline, because once you add a chemical, this concentration is higher than that concentration, then the mixture is alkaline. Okay? And therefore that external chemical will be called a base. Okay? Now you are familiar with this solvent itself is actually an acid. Okay? This is acetic acid. So it is an amphiprotic solvent, looking at it as a solvent, so call this Ks. That is Kw because the solvent is specific for water. Okay? So here we just use a Ks now, instead of Kw because it's not water. So the Ks value will be unique for this particular solvent. We will look at that later. So the acetic acid behaves as a solvent, right? If you have a stronger acid mixed with acetic acid, then acetic acid is actually a base. Okay? So this is an acidic character, and this is a base character. Okay, so the correct definition for the equilibrium K is Ks for solvent. K solvent is equal to the activity for the acidic species multiply the activity for the base species. Okay, just like that, the two multiply. Okay, now specific to the solvent Kw. Kw is water. That is 10 to the minus 14, right? Kw. You take the log scale, then it's equal to 14. pKw is equal to 14. So, under that condition, for pure solvent, then the neutral pH is half of this value, right in the middle. Neutral pH is 7. Now, for sulfuric acid, it's 3.6 amphiprotic solvent. Well, there's not many acids stronger than sulfuric acid, but it could behave as a base, with a stronger acid than sulfuric acid. So, if this is solvent, then the neutral pH for sulfuric acid is half of this value, 1.8. Okay, so when you tell other people the neutral pH, you need to be specific for the solvent. Just that water is the most popular solvent, so people are familiar with pH equal to 7 is neutral. But then if you change a solvent, then the neutral pH is different value. Okay? So and so forth, turn to a methyl alcohol that you can relate easier. The pK solvent is 16.7, so the neutral pH is half of this value. So ethyl alcohol, neutral pH is half of this value. Now, ethyl alcohol is used, the second solvent to water in titration. Well, for reason of that, your sample may not be soluble in water, so you use alcohol to dissolve your sample, then do acid and base titration, then your neutral pH will be half of this value. Another reason is you want to extend the sharpness of the endpoint. In water, it starts at pH 7, right? And here, you can extend the value to pH 8 point something.